Yeah, so now coming from batch learning to our batch processing to stream processing, well, many interesting applications. I think I don't need to tell you, but it's here on the slide, so I tell it to you. So many interesting applications, of course, nowadays come from dynamic environments, come from streaming environments. The data is generated over time. So for example, you have customer transactions in your, I don't know, Google, whatever, and of course the data is generated over time. So every day you have thousands of customer transactions, or you have call records, you have customer click data, you have social media interactions, and of course you have all those IoT and Industry 4.0 things like sensors somewhere in production plants and stuff like that. Yeah, and they produce data am laufenden Band, on the running band, so to say. So yeah, that are typical streaming environments. And batch learning is obviously not sufficient anymore because the data is now never ending. So what is the training set actually? Yeah, so if the data is never ending, what kind of data should you use for the training of a classifier or for computing your clusters? And obviously multiple access to the data is not possible and also not desirable, because I mean if the history is potentially infinite, which is of course not the case, but very, very large, and maybe data from 1 year ago is somehow obsolete because yeah, things, patterns may have changed, then it's also not desirable to access data from the past. Yeah? And also, yeah, since the generating process is also subject to changes over time, so also changes and evolves over time, the patterns, of course, may change, may be evolving, and the algorithms should also respond to the changes. So the patterns that you computed for one specific time frame may be changing in the next time frames. So algorithms should somehow account for that or address this pattern evolution. So new data instances coming in should be incorporated into the patterns and maybe change the patterns, while you may want to forget older data instances because they are outdated, obsolete, or whatever. Yeah. So all those things, which are now a little bit on the generic side, have to be considered when you're talking about data streams. Yeah, here are some examples which I think we should go through quite quickly. So here is a Twitter stream for the hashtag refugee crisis. You see that the slides are somehow 2-3 years old, and of course, yeah, the Twitter stream for this hashtag, or now probably it's for the hashtag Corona, had a big peak, and now it's going down a little bit. So at the beginning of the at the beginning of Corona, of the Corona crisis, people were probably talking much about oh, we should take care and lockdown and blah blah blah, and now it's probably a little bit different. So now it's people talking more about maybe vaccination or herd immunity, or yeah, Lockerung from the lockdown and stuff like that. Yeah, so people talking about different things in different stages of crisis or whatever. So and that will be probably also reflected in the Twitter stream, very, very likely. Yeah. So the patterns, the topics, the clusters probably, which represents the topics people talk about, changes over time. And here you see the trend in Google Trends of the search for environment 5 years ago here. So yeah, there was probably some specific incident happening where people were talking more about environment. So you see that, yeah, people talk differently or differently frequently on different time frames or different time slots, which is probably quite intuitive. Yeah, and here is my favorite example. So CERN, you probably know, the big colliding blah 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 facility in Switzerland. So they run a lot of experiments, obviously, and one experiment typically generates, or the experiments, all the experiments at CERN generate an entire petabyte of data every second. You have to consider that, a petabyte every second. Yeah, so they fire those particles around those LHC at velocities approaching the speed of light, okay, and they are smashed together, and they produce 1 petabyte every second. Okay, eat that. So anyway, and well, there was some interesting article, because people were wondering, how do they store, how do they metabolize this flood of data? And the guys at CERN said, well, you know, we do not store all the data, all that petabytes per second. We cannot do that. That's just impractical. Instead, from the collisions we run, we only keep the few pieces that are of interest. Yeah, so they run some specific filters. So they do they run the experiments, and simultaneously they run some specific filters, and they only store that data which they think are interesting. Yeah, so only the rare events that occur, which our filters spot and send to on over the network. Yeah, so in that case, still CERN stores 25 petabyte every year. Yeah, which is still a lot. Yeah. So the same as 1,000 years worth of DVD high quality video, just for comparison. Anyway, but this 25 petabyte every year can be analyzed and interrogated by scientists looking for clues in the data. Yeah. So just that you get a feeling on how big a data stream can be. Yeah. So even when your data stream, when your sensors do not record too much data per time frame, if the stream comes in at a very high pace in milliseconds or what, then over a considerably small or medium-sized period of time, the data explodes. Yeah, as you can see here, 25 petabyte every year is really huge, and they really filter out a lot. Yeah. So even if you don't generate an entire petabyte per second, just do some math with some megabytes, and you see that you will end up in a very, very large data set after a year or two. And you want to, of course, make use of that data. You want to analyze the data. Why should you record it otherwise if you don't want to do that? Yeah? So that's clear. Anyway, so here's another example. Network monitoring records, for example, TCP connections, connection records from LAN network traffic. Yeah, and a connection is a sequence of TCP packages or packets starting and ending at some well-defined times, in between which those starting and end points data flows to and from a source IP address to a target IP address. Okay, you probably know that. Under some well-defined protocol, hopefully, and the connections are described in terms of 42 features like duration, protocol type, service, flag, whatever. And each connection is also labeled as either normal or as an attack. And in the best case, you also know the attack type. So you have specific attack types like I don't know, spam, Trojanisches Pferd, or whatever. Yeah? Yeah, and most of the connections are usually normal, but occasionally there are bursts of attacks at certain times, and you want to classify all those connections. So that is a typical outlier detection or classification problem, and those attacks, you may imagine, somehow changes over time. The normal ones probably stay the same most of the time, but still they may change. The characteristics of the normal connections may also change, but at least the characteristics of the attacks will typically change over time, because the hackers get more creative, and so on and so on. Yeah. You can access a data set which contains those network monitoring records here on this URL. That was a challenge back in 1999.